Bling. Thinking in geometry node. Yikes. Blender is a program for making 3D things, 3D game characters, and pretty much everything else. The way things are done in the 3D world is that you start with a 3D primitive, like a cube or a sphere, and then you apply modifications or modifiers. For example, you can extrude faces of a cube with your mouse. Or you can apply an automatic modifier such as solidify, which for an unknown reason will go inside your cube and make a little home. It will give the insides of a cube walls for some reason. Perhaps it sees the faces of a solid cube as a thing that needs solidification. You can mix and match modifiers too. You can send a solidified cube into some other modifier. As a side note, nobody yet knows what happens when you solidify a solidified cube. You get a second floor, maybe. There's maybe 50 modifiers that do odd but useful things. And then there's this really crazy one called geometry nodes. When you select your cube and apply a geometry node modifier, you get to see this beam of geometric information flowing from the input of the modifier all the way out to the output. These beams, or node connections, or node trees, or in general, geometry node blocks, are not a new idea. It is a drag and drop programming language, not quite a proper user interface, and not a boring old programming language. It is like a subway map. You can follow the connections and get a good picture of where things are happening. Hollywood uses similar languages for advanced computer-based scenes, and previously Blender used something similar to color 3D objects. A language called Pure Data allows you for music creation, among other things. And a program called Node-RED can help you program web servers and web pages and templates. Pretty cool stuff. To return to our cube with a geometry nodes modifier, if you cut the stream of the geometric information inside your geometry nodes modifier, the cube will simply disappear. It is scary at first, and then it gets worse. That input no longer reaches the output. The geometric information is cut, and it won't reach your screen, at all. Here, in this visual programming language, you can also modify geometry. But you don't get something for nothing, like with the solidify modifier. Now you have to really sit down, probably with a pencil, and try to figure things out. This is where this poem becomes a little bit unhinged, so better grab onto something. This sub-modifier world, this inner world of sub-primitive things, does not aim to speak with a human language. It won't try to say, solidify, where you can sort of kind of hope to try to imagine that something is about to kind of become solid somehow, somewhere. Here, if you want to do something, you have to look at other people doing stuff and remember it. You have to read documentation, which will, for example, seem to try to help you. For one, it will break down long pages into sections. And sure as heck, they will start with a title that someone carefully highlighted and made bold. But often, just to mock you, to try to break you, to try to make the documentation writers look special. But after a while, you will be able to do stuff. You can make your own solidify thingy, sort of. If you take a cube and add a delete geometry node and set it to delete the cube faces so that you are left with a kind of a wireframe, and then convert the resulting wireframe lines into a curve, which is more important than just a plain line and has a whole lot of extra tools, then you will find yourself with a new starting point, a curve that looks like a cube, and lots of little tools for curve operations. And here you can dress up your curve that was once a cube without faces with another curve, which will gently trace all the lines and thus solidify your main curve or wireframe. And I did just that to create the main decoration for a ring I was testing. Except that instead of a cube, I used a low-resolution sphere to have few extra lines going back and forth. So you see, there is functionality here, but you have to know to delete some geometry, and you have to remember that curves are treated with extra care and respect and have lots of little functions, such as dressing up one curve with another. A process that I have repeated to create the main body of the ring. Here, the curve that I was using to dress up my ring or curved circle is something I manually created with my mouse. I wanted total control over how the ring feels, and I actually repeated this step one more time so I could fuse into the main body a much more geometric looking dress-up curve on the outside. This way the inside of the ring will be super smooth, while the outside will have an interesting little polygonal pattern. And finally, I had to pause, because when you dress up a curve, it is a whole operation all at once. But to position the main decoration on a ring, I only really need just one special spot. I didn't want to slide around a ring or dress up anything. I just needed the correct coordinate of the top of this ring. Asking for the top turned out to be a little bit too much. I could have done it, but it would have added extra math. And it is a good idea to keep everything inside geometry nodes as simple as possible. For example, any addition to a ring is just about the size of a borough on a New York subway map. So by the time you add 5 non-trivial things, your program is just about the size of an entire New York subway map. And it turned out that I wouldn't get a coordinate for my ring decoration. That is way too much to ask. Kind of. You have to gently build up information as you work with your curves. And by the way, curves are so special because they are simple. A mesh, such as that of a small, smooth torus, can have hundreds of thousands of vectors of geometric information, where if you start with a curved circle, you will have just about 10 units of information. In computer world, everything starts at 0, including bugs, called fence post problems. Because when you start at 0, your number of cats is 2, but you actually have a third cat. Or possibly you only have 1 cat. Or 4 maybe. Anywho, 0 is a really special number. Because it is super weird. And in the beginning, always in the beginning somehow. So it's a really good spot to weld the decoration of a ring to. And in geometry nodes, you would say, convert a copy of my curve to point. Another useful tool. A point is a reference point. It has XYZ, but also a radius. And you can attach custom calculations to it as of the recent Blender 3.2. So here, to place that decoration at spot 0, wherever it may be, we say distribute decorations to points, and this will immediately do what we are trying to avoid. It will create as many copies of our decorations as there are points and as we don't need. Blender and operations in general are at their simplest when they are completely complete, because you never have to wonder what you got. You got all of it all the time. So now that the decoration has been distributed to all the points, and we have the most uncomfortable ring in the world that can't fit a finger, we say, hey, distribute on point node. I'm going to select just one point, point 0. Whenever something is doing all it can, there is usually a selection option, which is a way of saying select only those parts of a thing. So we select the part numbered 0 by connecting Boolean math node, and in the A field we attach an index node which holds index numbers of points, and then in the B field we enter our magical number 0. So we are selecting a point with the index value of 0. And now the decorations are no longer distributed around the entire ring. They are just at the point with index 0, meaning that we have just one decoration. But now it gets even worse. I mean, a lot worse. Because you want to have smaller supporting decorations on each side of the main decoration. And you want them to grow smaller and smaller as they move away from the main decoration. There is no easy solution for this. There is no trick that we can pull here. Right after we converted our curve to reference points, we have to start doing math with the cheerful little chipper math geometry nodes, which are the ultimate proof that math is fun and easy when it is done right. Let us say we have 10 reference points that we converted our curve into. And no, we will not call it endpoints, none of that nonsense. We need to take this 10 and make the center special, because that is where smaller decorations will pop up and start getting even smaller. So to crack number 10 in half, we have to position it over 0. And then we just throw it down as if the 0 was the top of a pyramid. So to pull it back on a number scale so that the middle of the 10 numbers is over 0 or becomes 0, we need to know the half of 10 and then subtract it from 10. So we are pulling the 10 back into the minus world. Now our numbers go from -5 to +5. And here things get really easy, because we can just map -5 to +5 with a map numbers node. This node will ask us what the minimum from and what the maximum from is, and we enter -5 and 5. And then it asks us what the minimum to and maximum to is, and here we say -1 to 1. This will create a series of 10 floating point numbers, doubles, that are now squished between -1 and 1. And since we want things to be uniform on both sides of the ring, we want to run the numbers through an absolute function, which gets rid of that minus. There's an inversion that you have to perform here, depending on how you configure your ring, so that zeros become ones and ones become zeros. Because we didn't start at 0, we started at 1, that was once a -1, and then we went over to 1. That means the 0 that was the top of the pyramid is where index 5 is, not where index 0 is. We want to keep the zeros together, which in the world of rings means at the beginning and at the end, at index 0 and also at index 9. And here finally we assign this number to the radius of our 3D reference point for safekeeping. And now, as we instantiate decorations on the surface of our ring, we have all the information we need to have everything centered around our center decoration. And side decorations that gently get smaller and smaller and smaller. The one thing that's really special about playing with numbers between 0 and 1 is that they double as percentages. So 0.5 is actually 50%. And when you have something big, such as a ring with 17 millimeters radius or some such, and you multiply it by 0.7 or 0.5, you basically scale it down by that percent. What can I say? If something is uniform, like rings, then it is almost certainly programmable. And with a little bit of patience, a bunch of naps, and some sunny days, you can create a generator of rings, generator of all kinds of blings. The details on such a ring are almost too much for today's technologies. We may not have rocket packs, but you know what? Let's face it, flying with a rocket pack on your back is really silly and super weird. But what we do have is visual programming languages that are just enough to open a whole new world of creativity and invention and bling. Procedural modeling is here to stay. From procedural jewelry to furniture, shoes, and maybe even haircuts. And hats. Hats that perfectly match your haircuts so that everything has perfect geometry.